This is page 22 of our booklet. These trig identities are pretty important for future math classes. You want to make sure that you are familiar with them. I'm not going to make you memorize them, but be familiar with them. Here's a problem that says the sine is 4 over 5. Now we know that that is our opposite over hypotenuse, or we could say that this is our y value over our radius. So we know that is our y value and our radius. Now, this is important. It tells us that this angle is in quadrant 2. And in quadrant 2, the cosine is negative. So if I know theta is between pi over 2 and pi, I'm going to be in this area here. The y value is 4. My radius is 5. And that's all I know right now, because that's what's given to me in the initial problem. Now it says to find the other 5 trig functions. Well, I am going to use this trig identity, sine squared plus cosine squared equals 1. It looks a lot like our Pythagorean theorem, and so we call this a Pythagorean identity. There are 2 other ones as well. Whenever you see one of your 2 trig identities and a 1, have your mind say, oh, that could be one of our Pythagorean trig identities. So I know sine squared plus cosine squared equals 1. I have 4/5 plus cosine squared equals 1. I'm going to subtract 4/5 from both sides, or 4/5 squared from both sides. So cosine squared is going to equal 1 minus 4/5 squared, and I take the square root of that. Now we have to have the exact value. You're going to have to do some work on a scrap piece of paper. Then when I take the square root of anything, it could be a positive or negative value. In this case, I'm in quadrant 2, and my cosine is going to be negative, because that's my x value. I go over negative and then up positive. So I'm going to take the negative value of this. So this would actually be at 3, negative 3. And then I can find my other trig functions. So this is I have my sine and cosine. These are the reciprocals. The tangent is going to be my y value over my x value. So it's negative 4/3. The cotangent is that reciprocal. Now let's do the same problem with a second approach. Both approaches are fine. It does not matter unless it tells you something specifically. I know my sine is opposite over hypotenuse. My opposite is 4, my hypotenuse is 5. So drawing a little picture here, 4 and 5, here's theta. What is my adjacent side? Well, I can use my Pythagorean theorem, a squared plus b squared is c squared. When I solve for this missing side, it could be a positive or a negative 3. Because we're in quadrant 2, this adjacent side is negative 3. Then I would find the other 5 trig identities as we did up here, with knowing our hypotenuse, our opposite, and our adjacent, which we figured out was negative 3.